Hello, my favorite PreCal class. I started calling you calculus. Maybe that's because I want you to take calculus. I like you guys. I would love to have you again in my calculus class. Anyway, let's talk about some more limits, okay? This time analytical. When you see that word analytical, think algebraically. It means you got to use some algebra methods, okay? Alrighty. Here are your steps. My nice little graphic organizer. Isn't it just lovely? But anyway, first step. Try direct substitution first. That just means that whatever x is approaching, take that number, plug it in the function, see what you get. If you get a number, you're done. That's the answer. If you get a 0 in the denominator, dun 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 dun, that you know it's a big no-no. That's undefined. You can't have it. Then you've got to use some algebra to do what we call redefining the function. Okay? Here's some tips right here, depending on what kind of function you have. Whoa, hold on. All right, let me back up. Here we go. All right. Yes, a rational function. Okay? You're going to factor it, cancel stuff out. All right? Radical function, use the conjugate, cancel stuff out. Complex fraction, use your least common denominator, cancel some stuff out. If it's a trig function, use one of those limits that you were supposed to memorize. Refer back to your lesson 4 handout. It had all of that stuff up there. Okay? It was number 14 on that handout. Alrighty? After you've done these methods right here, you simply try direct. Whoa, I did it again. Man. Okay, here we go. Alright, try direct sub again. Okay? Alright, let's get into some problems here. Okay? First one right here. The limit as x approaches -3. What we're going to do is we're just going to plug this in. -3 over -3 plus 2. That gives me -3 over -1. My answer is 3. I got a number. I'm done. That is my limit. So the limit as x approaches -3 of x over x plus 2 is equal to 3. Yes, this is how you write your answer. Okay? And you're done. Alright? No big deal. The big deal happens when you get a 0 in the denominator. Okay? So if you have a rational function, just check out the denominator, okay? And you can do that in your head. Just plug in a -2 right here, all right? So you can do this in your head. I'm going to write it down this time, okay? That's going to give me 4, okay? -2 is 2. -2 again gives me 0. See, all this right here, it works out to be 0 in the denominator. And again, this is what I want you to be thinking. I don't really want you to have to write this down. So this is my little think bubble. Do that in your head. Okay, you don't have to write that down for me. So, but what we did is we put -2 in the denominator. We've gotten a 0. Okay, so since this is a rational function, I'm going to do what my nice little graphic organizer over here told me to do. I'm going to factor, then I'm going to cancel some stuff out. All right, now, you got to be careful with notation. Alright, AP Calculus is a biggie for notation, so that's why in PreCal I teach notation a lot. So we're going to factor this. So this factors into what? Let's say x minus 3 and x plus 2. And then on the bottom, this factors into x plus 2 and x minus 1. Alright, and see, we've got it factored. Now we're going to cancel out these common factors right here. We're going to cancel out the x plus 2's. You have to carry this limit symbol until you try direct substitution again. Yes, you do. Okay? Right here, this is what we refer to as redefining the function. Okay? When you use some algebra and you cancel some stuff out, then you have redefined the function. Alright? Now we try direct substitution again. See, this time when you put -2 down here in the denominator, you're going to get a -3. So you're going to be good here. So plug -2 into both top and bottom. Yes, I want to see this part because I love you. Alright, and this is going to give me what on top? -5. And on the bottom, what? -3. That simplifies to be a positive 5/3. So my limit as x approaches -2 of Yes, we need to write this down. X squared minus x over 6. Not over 6, minus 6. And x squared plus x plus 2 is equal to positive 5/3. This is so easy. I love limits. Okay, let's take a look at number 4. This time what we have is a radical function down here on the bottom. And when you plug in your 16, square root of 16 is 4. 4 minus 4 gives me 0. So this is going to cause a 0 in the denominator. So what I'm going to do is I'm going to multiply the top and the bottom by the conjugate of whichever part has the radical. In this case, it has the denominator. The denominator has the radical. So my conjugate is 4 plus the square root of x. Now, hear me on this and hear me well. And I mean it, hear me well, okay? Do not multiply out the numerator because you are looking for something to cancel. If you want to cancel factors, it would be crazy to multiply this out and then have to factor it again just to figure out what's going to cancel, okay? The part that you do want to multiply out is the part that you're trying to get the radicals out of. See, when I multiply my denominator by the conjugate, I'm getting the radical out of the denominator. So it's the denominator I definitely want to multiply out. But the numerator, I don't. Okay? Now, conjugates, you just have to multiply first and last, right? So that's going to give me 16 negative square root of x times positive square root of x is negative x. Do you see what I'm talking about here? Can you see how easy it is to actually see what's going to cancel out right here? And you wouldn't have seen that if you had multiplied out your numerator. Okay? So, we have redefined our function to be simply 4 plus the square root of x. So now we're going to do direct sub again. Okay? So we're going to put 16 in the place of x, and that's going to give me 4 plus 4, which is 8. There's my limit, and I'm done. So the limit as x approaches 16 of 16 minus x all over 4 minus the square root of x equals 8. We actually did that same problem in the last lesson using the numerical method. Okay, you go back and look at it. It was probably number, I'm guessing it's probably number 12. Okay, all right. Let's look at number 5 here. All right. This time we do have radicals, but notice they're in the numerator. And when you plug in that 10 in your denominator, you're definitely going to get a 0 here. So you know you got to do some work. All right. This time, since our radicals are in the numerator, then we are going to multiply top and bottom by the conjugate of the numerator, because that's where your radicals are. So that's going to be the square root of x minus 5 plus the square root of 5. Okay, now again, just like I just told you a while ago on the last problem, when you use conjugates with these radicals, your radicals disappear in whichever part of your fraction you're using the conjugate for. In this case, we're using the conjugate for the numerator. What that means is we want to multiply out our numerator this time, but not our denominator. Okay? So whichever part of your fraction you are using the conjugate for, okay, multiply that part out. Square root of x minus 5 times square root of x minus 5 is x minus 5. And then negative square root of 5 times positive square root of 5 is negative 5. Remember, they're conjugates. You only have to multiply first and last terms. Okay? Now, on the bottom, these are not conjugates. Do not multiply them out. The only thing you're going to multiply out are conjugates. If they're not conjugates, don't multiply them out. Leave them in factored form because, like I said, you're looking for something to cancel. It would be so crazy to multiply all this stuff out and then try to factor it again. Because factoring it, oh my gosh, that's going to be a beast and you don't want to do it. Okay? So what I've got here, Lord have mercy. So what I've got here is, that's going to become x minus 10. Look at there. You probably already saw it before I wrote it down. Which is going to cancel with this good old x minus 10 on the bottom. Do you see what I'm saying? You're looking for something to cancel. So don't be quick to multiply stuff out. Okay? So, these cancel. I am left with the limit as x approaches 10 of 1 over the square root of x minus 5 plus 5. Okay? So, now I'm going to do, now that I have redefined my function, notice I carry my limit symbol all the way down with me until I have redefined my function. And now I'm going to do direct sub again. So I'm going to put that 10 in the place of x. So that's going to be 10 minus 5 is 5. Oh, I forgot my radical right there, didn't I? Ooh. Okay, and that's going to be 1 over 2 square roots of 5. And to rationalize that denominator, I'll get square root of 5 over 10. And that is my answer right there. Okay, so the way you write your answer, yes, you get to write all that stuff out again. Okay, is equal to the square root of 5 all over 10. Okay, all right. Complex fractions. All right, your nice little graphic organizer over here. Use your least common denominator. Try to cancel something. Okay, so I've got to multiply top and bottom by my least common denominator. Now, the top of this complex fraction is just x. The bottom of this complex fraction is 1/6 plus 1 over x minus 6. So, my least common denominator here would just be this denominator, 6, times that denominator, x minus 6. So, I am going to multiply top and bottom by that least common denominator. 6 times x minus 6. And multiply all of this, 6 times x minus 6. Okay? So the limit as x approaches 0. All of that multiplied together will just be 6x times x minus 6. Again, don't multiply all this stuff out. You're looking for something to cancel, and if you multiply it all out, when you're done with this denominator down here, you may not see the factors that you're going to be canceling, okay? Now, you've got to multiply all of this times 1 over 6 and times 1 over x minus 6. So if I say 1 over 6 times x minus 6, 6's cancel, I'm left with x minus 6. Plus, now I'm going to multiply 1 over x minus 6 times 6 times x minus 6. X minus 6 is cancel. 1 times 6 is 6. So 6x times x minus 6 all over. That cancels with that. I'm left with x. This x can cancel with that x. I have now redefined my function to be 6 times x minus 6. So I'm going to try direct sub again, put a 0 right there. 6 times negative 6 gives me negative 36. So that is my limit. So my limit as x approaches 0 of x over 1 over 6 plus 1 over x minus 6 is equal to negative 36. I'm going back to check because I did make sure I didn't do anything careless there. Yeah, we're good. Okay. All right. Last two, we have some trig. Again, refer to number 14 on yesterday's lesson 4 handout, okay? This is actually one you're supposed to memorize. If these coefficients right here are the same, then sine of ax over ax is just equal to 1. As long as your x is approaching 0. Now, if x were approaching any other number, we'd have to do something different. And we're not going to get into that until you're in calculus, okay? All right. Here, this is the same, except this is the second part of I think it's 14F. It is. It's your lesson 4 handout. Look at number 14F. I gave you 2 theorems, okay? One of them is when these are the same. Essentially, what you're doing is you're just dividing these out. 3 divided by 3 is 1. Okay? And here, if they're not the same, you still divide them out. It's just this doesn't divide evenly. So you're just left with 4/5. And if you blinked, you missed it, and you're done with those limits. I know, you want like 52 of those on the test. Not going to happen. But anyway, we're done with this lesson. Aren't you glad? All right. Hey, y'all still keep it 100 for me, all right? Because it's going to be a tough week with my mama in the hospital, and I need you guys to be nice to me, okay? All right? Okay, y'all know I heart you, all right? And I'll be seeing you.